Let's proceed to the question 8, which is about Python implementation. It requires to implement both algorithms in Python. Let's see the implementation steps then. Implementing these algorithms in Python is straightforward using scikit-learn. First, we prepare our data by splitting it into training and testing is typically in 80-20 split, where 80% is for training and 20 for testing. For linear regression, we use uh, sklearn linear model. In linear regression, for logistic regression, we use sklearn linear model. Logistic regression would follow the same pattern, create an instant, fit the model to training data, and make prediction on test data. Finally, we evaluate our model by calculating appropriate metrics and generating a confusing matrix for classification. The specific metrics depend on the task. Let's see the evaluation matrix here. For linear regression, we calculate several metrics. RMSE or root mean squared error is the square root of the average squared errors. It's the same unit as the target variable, making it interpretable. R squared score indicates what proportion of variance in the target is explained by the model, ranging from 0 to 1. MAE, which is mean absolute error, is an average absolute difference between predictions and actual values, also interpretable. For logistic regression, we use classification, and for logistic regression, we use classification matrix. Accuracy is the overall correctness, precision shows correctness of positive predictions. Recall shows ability to identify actual positive cases. F1 score balances precision and recall. The confusion matrix shows the breakdown of predictions. Specificity shows ability to identify negative cases, and AUC measures the model ability to distinguish between classes. Let's see summary of the part 4. To summarize part 4, linear regression predicts continuous values and works well when relationships are linear. Logistic regression predicts class probabilities and handles non-linear boundaries through the sigmoid function. Both use gradient descent for optimization. The learning rate controls convergence. Python implementation by sklearn is straightforward, just a few lines of code. Different evaluation makes metrics apply for different tasks. For regression, RMSE, R2, MAI for classification, accuracy, precision, recall, F1 score, proper train test splitting ensures we get unbiased performance estimates on truly unseen data. So the conclusion to this video, you now understand the fundamental difference between linear and logistic regression, how gradient descent optimizes both algorithms, and to implement them in Python. These are core algorithms that form the foundation of machine learning. Thank you for watching the video, and I'll see you in the next part 5, where we will discuss the last two questions in the assignment, question 9th and question 10th. So stay tuned for the next video.